What's good, Year 11 General Mathematicianers? Mr. Herman here, coming to you on a Saturday afternoon. It is raining outside. Perfect weather for me to make a video for you guys. I could run around outside, but no. Anyways, lesson 2, exercise 7b, scatterplots and their construction. So lesson 1, we looked so much into explanatory variable and response variable. And there was a lot of content to digest and hardly any maths. In this case here, we're now going to stray a little bit into the math side. You can understand what scatterplots are and delve a bit more into them later on within the lesson. But for now, let's look at the backbone, the basics of what a scatterplot is. So the first step in investigating an association or relationship between two numerical variables is to construct a visual display of the data, which we like to call a scatterplot. And the word scatter just means when something is scattered, it is spread out within a domain or within a certain space. Alright, so to scatter something, so sometimes we scatter confetti or we scatter glitter. I feel like I'm saying this as like a secret type of thing that I do over the weekend, to just scatter glitter everywhere. No, not the case, no. To scatter just means to spread out over within a region, and we scatter this over, in this case, a plot. And it's represented either by a dot or on your calculator by little squares, okay? So in the first question here, in the first example, we're going to construct a scatterplot of the marks students obtain on an exam and the time they spent studying for the exam. So you can just imagine a certain survey was conducted over 10 students, and 2 questions were asked. How much time did you spend in hours, roughly, for your exam, and what was the mark you got as percentage for that exam? And the 10 students provided their answers. And what we're going to do is we're going to specifically put each student's mark or time, versus their mark. So remember, the time is the explanatory variable, or the EV, the one that explains the response, in this case, the mark. So the time that you spent will explain the mark. So this is the response. So in the scatterplot, each point represents a single case, and in this instance, obviously a student. When constructing a scatterplot, it is conventional to use the vertical or the y-axis as the response, as I just did here, and the EV explanatory variable as the x-axis. And a good way to think of this is explanatory, x for the x-axis. Okay, that's one way of knowing where to put your explanatory variable. So student 1, 4 and 41. So when student 1 has studied for 4 hours, the associated mark that student 1 got is 41. So we just put a dot there. Now we've just put student 1 4, 41 just as an example. When you're doing a scatterplot, you don't have to label every single one of those dots by which student or which person it belongs to, and you don't have to give the coordinates. We've just put that there just for this example. So we're going to do the second student. Okay, so student number 2, the time they spent on studying, 36. Big jump from 4 to 36. So 36 is here. And the relative mark for that, you would expect it to be a bit higher than 41. It is 87. So 87, pretty close here. And there's our second point. So time spent, 36, 87. And we've ticked that one, done. Let's go to the third one. I'll do one more example and then I'll pause the video and complete the whole thing so we can have a look at what it looks like. But for now, 23 and 67. So time spent in hours is 23, 20, 21, 22, 23, which is about here. And the relative mark for that is 67. So this is the fastest, 67. Now, you'll notice that scatterplots don't have to be spot on precise at their point. I mean, the more accurate you can get it, the better. However, at the end of putting all of these students' time marks in as a scatter plot, you will see hopefully a trend, and that's the main aim for this, to see what trend we can extract from this. So for now, let me just do my thing and I'll finish this off. Okay, to the best of my ability, this is the scatter plot based on the time and the mark for each student in hours and percentage. And you can see that there is definitely a trend going in the positive direction. So if we were to draw a line of best fit of some sort, it would lie directly within the middle there. And that's all a scatter plot is. So let's look at the elements of a scatter plot. Let's look at this example here. This scatter plot shown to the right has been constructed from data collected to investigate the relationship of the link, remember the link relationship, between the price of a second-hand car versus its age. Now we can make the assumption already, without even looking at the graph, that the older the car is, if you were to buy it for a second-hand price, the cheaper it will cost. But there is a big thing to consider in this case. Dependent on what type of car it is, obviously. Okay, there's all these factors and variables that come into play. But it's safe to say, generally speaking, that the older the car is, the cheaper it will cost. So using the scatter plot here, we're going to answer the following questions. The first question is, which is the explanatory variable and which is a responsive variable? Well, we already know from the previous explanation that on the x-axis, the explanatory variable is always going to be there as the x-axis. So in this case, the EV, explanatory variable, is the age. Meaning the response variable is the price of the car. And that makes sense. The age will explain the price. The age will give an estimate of what the price could be, but the price doesn't necessarily give you the estimate of the age. So this one explains, this one is the response. And B asks how many cars are in the data set. Well, that just really depends on how many dots we can count in the scatter plot. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 cars. So maybe 12 people had been surveyed and gave the age of their car and the price and provided it for this information. So 12 cars in this case. And C, how old is the car circled and what is its price? So the one circled here, the age of the car circled is 6 years. 6 years old. And the relative price, now it is given to the thousands. Now it is just slightly above that line. So 12, if this here was 13,000, you can say these are going up by increments of 3, 4, 5. So 2, 4, 6, 8. You can say that this here, the price is $12,200. Now you're wondering, how did I get that price? Well, I know that along this line, this is 12, and remember the price is given in thousands. So this is 12,000. To get from 12,000 to 13,000, I just put little increments of 200. So there's 2,200, 2,400, 600, 800, all the way to 13,000. And I know that that increment went up by one of them, so by one of these 200s. So I put 12,200. Now remember, you are interpreting the information on this graph. If the dot lies exactly on the line, or even easier, the intersection of these blue lines, then of course you can provide your answer. But if it's somewhere along here, it makes it a little bit tricky. So when it comes to marks, provided if you're going to answer a question like this on a SAC or an assessment, then we are lenient. You're not going to lose too many marks unless it lies either on a line or even on the intersection. Okay. That's it. That's all there is to it, to getting the elements of a scatter plot. The last thing here, we're going to be looking at how to use the calculator to create a scatter plot. Now, the example that has been provided to you on the board notes, I was going to show you that example. I'm actually going to show you the example via this here, this example here. So when you get your calculator out, the first thing you're going to go into is, when you're in your home screen, you're going to click on statistics. Okay, so we're using statistics. We've used it before. And just make sure that you've cleared everything on here. Edit, clear all. Okay. Under list 1, you're going to choose one of these lists. List 1, I'm going to put time in hours. And I'm going to list all the digits here. 4, 36. It doesn't have to be in numerical order. It can just be in the order that's being provided. I'm making sure that when I put my last digit in, 18, it should be 10, 8, that I'm not just leaving it there. I'm pressing execute on the calculator, or in my case, I'm pressing enter, and then we'll get the list of 10 here. Then I'm going to go back to up to the top and go to list 2, and here is where the associated mark for that time is given. So I can't scramble this order. The way this order has been given here has to be in the same order for mark, because it belongs to each student. You can think of each student as this list here. So don't mix this up. Don't just put any numbers. I have seen it before. It is rare, but I have seen it before. 87, 67, 62, 23, 52, 61, 43, 65, and 82. Done. All right. You've got your list for the 10 students. Next thing we're going to do is we're going to click on this button here, and this is going to set what type of statistic graphs that we want. We've used this button before, and we use this for putting in histograms and also putting in box plots. This time we're going to put scatterplots, and by default it leaves it as scatter. Okay, so all you've got to do is just leave everything in its custom function, the default function. Make sure list 1 and list 2 are chosen, and your draw is on. And we set that. So we've just set it. Okay, nothing's going to pop up in this case. We want to actually now see this graph that we set. So we're going to click on this button here, and what will happen is the scatter plot will be provided. And here we can see that there is a trend that we obviously got from the example. And you can see this trend is going in a positive direction from left to right. The last thing we want to be able to do is we want to make sure that we can visit each point. And so we click on this button here. It has a little X, Y, and an arrow. And by clicking on this, a pink cursor will pop up, and it will show you the values for whatever you put in list 1, the explanatory variable, in this case the time, and the associated Y value or response variable, in this case mark. And you can go ahead on your cursor pad and go across for each one. And it goes across by the order that you put it in within the list, not by numerical order. Okay, so because my first number in here was the first student was 4 and 41, when I click across, it's going to jump straight to the next number, which is 3687, which can be found here. It's not going to go across the actual point itself. Okay, so just be wary of that. I have seen students be caught out where they went across and they assumed the next value was 36, which was here. That's not the case. Okay, it goes by list order. And that's how you put Scatterplot into your calculator. Very, very simple stuff for lesson 2, exercise 7b. Go ahead, check your log sheet, see which questions you need to do, and I will see you in the next video. Bye bye.